For today's video blog, I want to use what is arguably my favorite technology, the whiteboard. I'm going to cover something that I've talked about before, which is architectural decomposition. However, I find that sometimes having a live demonstration gives you a better understanding, a better feel for what I mean by that. So let's dive into it. Let's take the arbitrary idea of any control algorithm. It could be that we are controlling a braking system, it could be a throttle control, it could be a nuclear power plant. At the topmost level, you have some big box, a big squeaky box apparently, of controls. Yep, we're going to throw that pen away. When you think of the big black box, though, that needs to get broken down pretty quickly. For starters, inputs. Controls. Outputs. So that's the initial decomposition, showing the connections between those things, because obviously this is still within the same boundary. This decomposition is just to separate out the control algorithm from the inputs and outputs. Now these inputs and outputs can further be decomposed in the following way. So this gets broken down then into two parts, which is what I'll call raw and scaling. Now this is conceptual. These may actually be together in one unit, but conceptually you want them there. So the raw is something like your D to A, A to D, PDO encoder, thermistor, any sort of raw signal. We're getting data in digital format, bits, counts, whatever it may be. The scaling takes up raw information, transforms it into engineering units. Because obviously what you want to pass from the inputs into the control algorithm are engineering units. Ideally, your control algorithm should never be dealing with, the raw bits, because it's not intuitive. With a lot of unnecessary rescaling, that's how errors are introduced. Likewise, when you have the outputs, you see that same thing mirrored. You do accept it's mirrored. The scaling comes first, and it gets converted into the bits, counts, etc., and then goes to the outputs. The control algorithm, topmost level, this will get broken down into multiple bits itself. A simple, quote-unquote, simple control algorithm may have, multiple functions within it, feedback loops, etc., and each of these could in turn be broken down into functional units. Ideally, you want to have the idea of a lowest level where that's where your actual calculations are taking place, and these higher levels are more of the topology. So I'm thinking of, let's say, a braking unit. I might have something where I am doing a check for, am I in a lockup situation, ABS event? That would be one of these blocks. Maybe that gets broken down to several different points that have a environmental check and that have a pressure calculation subsystem. So maybe I have three of these blocks, and maybe some of those would have subsystems, and they all get integrated together in that way. The one part that I'm not showing in here is how this is scheduled. I'll leave that for a future talk, but scheduling does come into this, and that scheduling may be from the OS at the outside, or it may be something that's purely derived from the topology of the model. Hope you enjoyed the presentation. Thank you.